So guys, what do you think? What are the chances that sir will be taking a class? Or what are the chances the sir will not be taking a class? So here I am and today I am taking a class. So we are talking about chances. What are the chances of certain thing happening? What are the chances India will win the match? What are the chances that it will rain tomorrow? What are the chances that tomorrow the sun will rise? Yes, there are sure chances that that event would be happening. So we are definitely contemplating multiple events, and for this we are calculating probability. Probability is how much chance of certain event is there. So hi, welcome you all at this amazing platform of PW, and my name is Aman, your favorite maths buddy. And today we are going to revise the chapter of probability for you. And as I mentioned, this is a chapter which most of the students in mathematics like. There are two basic reasons behind it. There is no calculation involved. Yes, you heard me right. And secondly, there are no multiple formulas. This is a single formula, and when you start probability in grade 9, that formula is there. And when you end probability, there is no end to it because your life is a probability of events, multiple events happening. So what will be happening, you don't know. So we will be having only one formula that will be using entire time. So have a lot more fun in this session. We are going to talk about probability. What are the topics we'll be covering? As I mentioned, no formula, no much hectic things happening around. So first thing is theoretical probability. I'll talk about this concept of theoretical probability and how it is different from whatever you have learned till date. And then finally we'll be solving few problems on the concept of the probability. Few problems related to certain things. Favorite to examiner, like the case of rolling a dice, having a toss, basically tossing a coin, right? And thirdly, having playing cards. So playing cards, so people who like gambling or have this thing for relating to the playing cards. This is an educational video. Don't take it otherwise and make the best use out of it. Talking about the part of probability, let me start with probability first. Probability. Why we are talking about theoretical probability today? In grade 9th, when you learn probability, when you are basically introduced to probability, what happened over there? In that case, you were talked about that, let's say certain experiment is happening, or I would say a trial is happening, and in that certain things are in your favor. So let's say you are having an event, you are having an experiment where you have tossed up a coin. So you have tossed up a coin, there is a chance that you might get head, there is a chance that you might get tail. Perfectly right. You have basically tossed a coin multiple times, not simultaneously, multiple times. First you had it, okay, it's like me and my friend. Let's say there is Arya, one of my friend is there. So we have decided that we'll be playing cricket today. And initially who would be batting first? This is the most common issue, most common dispute among all of us, I would think of. Now, for this we are having a toss. And now, let's say I lost on the toss part. I'm not a very honest person over here, and don't take it literally. This is just an example over here. So what I told, there was some issue with the coin. The coin was not fair. It was not fairly tossed. So I want a second try. So again the toss was coin. Third time also I repeated the same. Fourth time also I repeated the same. Number of trials, basically 5 times the toss was coin. Probability. What we learned in this case was the total number of trials happening and how many favorable trials for me. For example, we were having in total 5 trials. So total number of trials were 5. I wanted that I should be winning. I called for head all the times, let's say. And in total there were 3 cases. There were 3 cases where head came up. For example, if I have to show, sorry. So these were the cases which were happening. So out of the total 5 trials, 3 times I got head. So the favorable one, the trials which are favorable to me were in total 3, and the probability was calculated as 3 by 5. Very simple. Over here, it was all on the experimental basis. It was empirical. Why it was empirical? It was empirical because we have the trials, we took the outcome. We have the trial, we took the outcome, and based on that we did. Not everything is empirical in our day-to-day life. things work on theory. You learn so much of theory in science that okay, there is a gas, this will react in this manner. There is a liquid, this will act in this manner. We are having water, it will freeze at certain temperature. The water will form vapor at certain temperature. The theory is there and then there is the reality. The reality might be different, the theory might be different, but learning theory is very important. So today we are going to talk about theory as per se. Sorry. Coming back over here about the theory and reality difference, or I would say experimental thing. In case of theory, we would say that when the toss was coined, so we were having a coin which was tossed, so the probability of getting head and tail is basically equally likely. When I say equally likely, 50% chances there that I will win the toss or my friend will win the toss. But when we had this trial over here, I had a favorable outcome 3 times out of total 5. So do you think it is a 50-50 answer? Think about it. Sorry. Is this a favorable outcome? 3 by 5? No, this is not a favorable outcome. Over here, it's not 50-50. It's in my favor. It's in my favor. So sometimes in case of experimental thing, it might indicate that the outcomes are not equally balanced. But in theory, that's not the case. In theory, we understand that if the number of trials would be increased to so many, up till infinite, in that case, what will happen? In that case, it will be 50-50. Let's say if I'm having 1000 total number of trials, and in that case, certainly, not certainly over here, I can say that the probability of getting ahead will be what? 1 by 2. 1 by 2. This is what theory suggests. Again, as I mentioned, reality is different from theory. Theory says that we will be having equally likely chances, but experimental thing will suggest otherwise. It doesn't mean that they go in different direction. Basically, they converge after a certain time period. And what is that time period? As I mentioned, the number of trials. If the number of trials are huge, if the number of trials are greater, there will be more proximity between the theoretical one and the experimental one. And what's specific in the case of theoretical one? In case of theoretical one, the specificity is that we will be having equally likely. When you are having a toss, when you are tossing a coin, basically we are having a head and tail, and there is a symmetry over there. So there are equal chances that I'll be getting head or I'll be getting tail. So 50-50% in terms of probability, 0.5, or you can say 1 by 2, So that is how the theoretical probability differs. In case of theoretical probability, we don't have to do again and again the experiment to show that this will be the probability. For that, we have a direct formula. And the formula is very simple to understand. It says the number of possible outcomes in the denominator, total, how many possible outcomes are there? For example, the basic example we were carrying on, head and tail. When you tossed a coin, only these were the 2 cases, right? Possible. So total outcomes are 2. What you want, what I'm interested in, I am interested in winning basically. I want to win. So I want to win the toss. So let's say I called for head and head was the thing which came out over there. So your favorable thing, what you want will be in the numerator, and what are the total possible outcome that will be in the denominator. So this is the case of theoretical and experimental, which we call as empirical probability. So in the case of class 9th, you learned about empirical thing. Right now you are learning about theory, and as I suggest, theory makes the foundation of everything. If you know the theory, you will better explain the experiment. So even if you are having a difference over there between theory and experiment, you will have a better clarity why that is the case. As I suggest, this is because of the number of trials. Less are the trials, so there will be a difference. But the more the trials, there will be less the difference. Alright. Now, moving forward, this formula is only one of the formula which we will be using throughout, and there is no other formula at all. Going further, we'll be talking about few certain basic terminology which is involved in case of probability. We are talking about outcome. I use the word event. I use the word experiment. What are these things? So let's talk about certain things. First of all, the first thing is experiment. Let's say we are having a dice. We roll the dice. So what are the possible outcomes? The possible outcomes are we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, we can get 6. Experiment is something which you are checking for. It's kind of a trial. So this is experiment. Through the experiment, we are going to get some sample space. Or you can say the possible outcomes. And what we are considering in theory? We are considering only the outcomes which are equally likely, or we are going to perform the experiment which are equally likely. For example, tossing a coin, it's a symmetrical coin. We are considering only the case either head will be coming or tail will be coming. There will be few smart students out there who will be thinking, sir, what would happen if the coin will not land either on head or on tail? No, we are not considering that case. The reason behind this is they have very minimal chance, very minimal, 1 in million. If the coin is perfect, that is also the case. Alright, please do consider that as well. So, the formula is important, and in case of theory, equally likely. The outcomes are equally likely. This term is important. Equally likely means fair chances. That means unbiased. We are talking about unbiased experiment. So, experiment should be clear from this itself. And the outcome, or you should say the possible outcome, is basically what we might get. Now, in this case also, when we might get something, so these outcomes basically which we are coming, what are the thing which I want? Definitely everyone is interested in what I want. I want certain thing. I want, let's say, 4. I want 4. This one. So I roll the dice, I get 4. I don't know, there will be some probability, right? So I get 4. So this is an event happening. In this possible outcome, there will be some event which I am looking forward to. There is an event that I will be scoring good marks. There is an event that India will be winning a match. There is an event that we will be having a good budget out there. I will be winning an election. I will be doing so and so. There are multiple possibilities. These are all events. This is what we are interested in. We are interested in event. So over here, I was interested in the event when we get 4 on the dice. This is one event. There might be other event. I am interested in, let's say you are playing a game of Ludo. Now, you are interested in getting anything above 4. That is also an event. So in that case, you will be interested in getting 4, 5 or 6. All 3 of them will work. So, event can have single outcome, or you can have multiple outcome. So, only 4, that is what the case of single outcome. If I want anything greater than 4, so 5 will work, 6 will work, not 4. I talked about only greater than 4. So 5 will work, 6 will work. That is also event. So event is different from experiment. Fair enough. Now, in the case of event, we have certain thing called as elementary event. What are elementary event? This is again a new term coming up over here. Elementary event. As the name suggests, elementary. When we are having a single outcome, that kind of an event will be called as elementary. Why I am quoting it? So that is being quoted over here because the sum of all the elementary events of an experiment will be equal to 1. The sum of all the elementary events will be 1. For example, if you are tossing a coin, so either you might get head or you might get tail. These are the 2 possible outcomes. So the event over here is getting head or getting tail. So getting head, the probability will be what? Going by the formula which we have learned, possible outcome in the denominator 2, and we want head, so 1 by 2. Same for the case of tail, 1 by 2. So 1 by 2, when added, what we are going to get? We are going to get 1. So elementary events, for the case of elementary event, the sum of all will be equal to 1. The best way of understanding this is, let's say I'm having a bag. Inside the bag, I'm having one red color ball, I'm having one blue color ball and one green color ball. 3 types of balls are there. Let me show you. One red color ball, this is one red color ball, this is one blue color ball and this is one green color ball. Right? If I ask you, sir, the probability of getting a red ball out of the bag, and over here, it's not that the bag is open. So definitely if you want, my favor is red ball. So definitely I'll pick up the red ball. So that's not an unbiased experiment. That's not an unbiased experiment. When we are going to have the unbiased experiment? When we are having a bag and we don't know what we are going to take out. It's a random thing happening. That's why random experiment. It's a random thing. We don't know. We don't know the outcome over here. So I take out any ball and that came out to be red. So the probability of red over here is what? Total possible outcome, I could have picked this one, I could have picked this one, I could have picked this one. In total, 3 cases were there. So in the denominator, possible outcomes are 3. The event which I am interested in, the event is where I get the red ball. So that is one of the case out of the 3. So 1 by 3. Similarly, the probability of blue ball will be also 1 by 3. The probability of the red ball is done, green ball will also be 1 by 3. These are all elementary event. Why they are elementary event? Because in all the 3 cases, we are having only one outcome possible. Elementary event, one outcome possible. So over here, the sum of the probability of red plus the probability of blue ball plus the probability of green ball. One of the last is green ball. All these when added will be 1. And this is what I have said. Sum of all the elementary events would be 1. This is how elementary event is important. And by now, I hope you are clear on the few of the terms. What is experiment? What is event? What are the possible outcome? Or slash I can say the sample outcomes, right? The sample space you can say. Going further, one more final concept. One basic theory I'll talk about, and after that thing is almost done. We are almost done with the session. Why I'm saying so? As I mentioned, only one formula to explain, and I have some basic vocabulary. I have given you the vocabulary. Then it's only about the application, and you'll be very, very happy. So next thing is, see, in the case of event, let's say I talked about an event. Getting head is an event. Getting head is an event and the probability of it is 1 by 2. Now, I am saying an event, that this was an event. So, exactly opposite to this event. That is, I have just put up a bar above H. So, basically, if E is an event, so not E is a different event, just opposite to it. This is an event, this is exact opposite event. So, not of H. I don't want H. So, the probability is, if you don't want H, ultimately what are you going to get? You are going to get tails. And I know the probability for tails is 1 by 2. Simple. Right? Very simple. So, event, not event. So, opposite. We call it as complement. Complementary. So, over here, the probability of these two, P of E and the complement of it, not E. This is the indicator, not E, will be equal to 1. So, I hope you have taken the note of these. Very simple things. What I talked about till now, I talked about theoretical probability, experimental or empirical probability. The difference between them, experiment, event, elementary event, and finally the complement of an event. One final note over here, which I will be ending the theory, and you will not have to further learn anything in the case of probability. That's much shortness we are having in this chapter. No theory at all. You will have a lot more fun. Even if a person is not liking mathematics, he will have a lot more fun in this particular chapter. If I ask you, what is the probability that tomorrow the sun will rise from west? What do you think? Sun will rise from the west. Listen carefully, from west. Generally, to our knowledge, it's a universal fact. That the sun rises from the east. And I'm not indicating over here that this side is the east. I'm just doing that for just my sake. So, east, the sun rises, goes into the west. rises from the east, goes into the west. So this is a 100% sure event that tomorrow the sun will rise from east only. So these events are sure events. These events are sure events. Sure events. Sure events means one probability, or you can say 100%. In terms of percentage, 100%. And opposite to sure events, there are events which are we show that will not happen. What are the chances? What is the probability that I will not end this session? What is the chance that I will not end this session? You might think there is a possibility, but no. I will get tired eventually. I need some food. I need some water. I need some bed to lie on. And in that case, I will not be able to continue, right? So I will end this session. Don't worry. And for that case, we are very sure that this is an impossible event that this session goes on forever. Nothing is forever. Our existence is for a certain time. The time keeps on changing. If you are having a good time, that will also last for some. After that, you'll have a bad time. So, daily you are having different kind of a day. Some day good day, some day other bad day. So, yeah, event, if it is sure, that will not happen. The event like where we are talking about the sun will rise from the west. No. That is not going to happen. So, that is a impossible event. Impossible. And for the case of impossible event, the probability is simply 0. That means 0% or simply 0. Ultimately, the point I am trying to convey over here is that probability, impossible, sure. Impossible, sure. So, will lie between these two numbers. Will lie between these two numbers. What, sir? I am repeating once again. Probability of an event. We write in this manner. Probability, inside bracket I have written E, that means of an event. Probability of an event. Over here I have explained. Complementary, not E. So, probability of an event will lie between 0 to 1. Always. There is no third case. There is no other case over here. We are sure that this will be the case. Either it can be equal to 0, that means impossible event, or sure event that it will be 1. It will be 1. So, that is the case. So, I might know that, okay, tomorrow morning I will once again come back and take a session. There is a very high chance for that, right? But today I am sure that I will end the session, go back to my home. So, multiple things. India will win the toss or not. India will win the match or not. Will it be raining tomorrow or not? Will the match happen or not? Everywhere there is a possibility. We are talking about certain events which might happen or not happen. So, we are interested in the probability of the event. Alright. So, if a random question comes up, in front of you where they say, tell us which of them cannot be the probability. So, someone told you 0.1, alright, 35%, alright, 12 upon 13, alright, and 14 upon 13. Among all of them, which one doesn't seems like a probability? Which one doesn't seems like a probability? What I told you, the basic rule is probability of an event lies between 0 and 1. Right? This is 0, not 6. Pardon me for my handwriting, that's not very good. Over here, 0.1 lies between 0 to 1. I hope you are comfortable dealing with numbers. 35%, that means writing in the term of fraction, 35 by 100, that is 0.35. Yes, it fits in our scheme of things. Third number, 12 by 13, we are sure less than 1. 14 by 13, or it is, 14 by 13. Yes, the numerator is greater. When the numerator is greater than the denominator, you are very sure that this will be greater than 1. And if that is the case, we are very sure that will not be a probability of an event, because it should go by this basic understanding. So now that is all we have in probability. I am not going to end the session immediately. Don't get so excited. This is the theory. We have talked about impossible event, a sure event, elementary event, the complement of it, or I must say not E, experiment, event, possible outcomes, all these things. Ultimately, one formula, and which was this one, a basic formula. In denominator, the possible outcomes. In numerator, the favorable outcome. How it works? Let's understand by few basic problems. So here we have the first problem. A very simple one. It says, there are 6 marbles in a box with number 1 to 6 marked on each one of them. Okay, so in a box we are having marble 1, 2, 3, 4, 5, 6. And the name given to them is 1, 2, 3, 4, 5, 6. The marbles were there. I have given a name. I have just used my pen and give them a name. 1, 2, 3, 4, 5, 6. They are asking, what is the probability of drawing a marble with number 2? Probability of getting a marble with number 2. So what happens? You choose one of the marble. So probability is total outcomes in the denominator. Total outcomes. Possible. Over here, you can add over here possible as well. Total possible outcome. When I say total possible outcome, there is a possibility I can take 1 out, I can take 2 out, I can take 3 out, 4 out, 5 out, 6 out, individually, not at the same time. So all of them are the possibility. In total, how many cases are there? In total, there are 6 cases. Total possible outcome 6. The event in which I am interested in, over here they have clearly mentioned. Drawing a marble with number 2. If this happens, that is in my favor. That means that is a winning situation for me. So among all the 6 cases, this is one of the case. So in the numerator, favorable outcome. And the favorable outcome is only one case out of the total 6. So 1 by 6. People do get confused over here saying that, sir, all 6 marbles are there. So 6 in the denominator. In the numerator, I want 2. So I'll write 2. No, bache, that's not how things work. This is the number of possible outcomes and the favorable outcomes, or I must say the cases where I would be getting only 2. So only one case is there out of the total 6 cases. And that is why the probability is 1 by 6. That is how things work. So answer is 1 by 6. Going forward. Now, as I mentioned, most of the cases are of 3 nature. First is tossing a coin, rolling a dice and playing cards. So here we have the question on tossing coin. Coin is flipped to decide which team starts the game. What is the probability of your team will start? See, in this case, it might be head, it might be tail. Whatever I call. I went for the toss with my friend. If you remember in the very starting, if you are consistent with the session, then only you will understand or remember this part, right? So I tossed a coin, I get head or I get tails. So whatever I called, only 2 possible outcomes are there. In total, 2 possible outcomes are there. Among them, I want 1. So the probability of that event is what? 1 by 2. Simple, the probability will be 1 by 2. You can call it 0.5 or you can call 50%. This basically is the conversion of fraction into decimal, decimal into percentage, whichever you are interested in. It's up to you. I hope this point is clear. Going forward. The next question, a dice is thrown. As I mentioned, the third case, dice is thrown. What is the probability of getting a prime number? So directly, if I would have asked what is the probability of getting 1? The answer would have been very simple. Total 6 possible outcomes. What I want 1. So 1 by 6. What is the probability of getting 4? 4 by 6, not 4 by 6. This is the mistake I was expecting from you. I haven't committed, I have done so that you become active in the session. It's not about the number what you want. It's about the number of cases which are in your favor. So among the dice, when I say we are having in total 6 possible cases. So the possible cases are all of them 1, 2, 3, 4, 5, 6. Over here, if I talk about I want 4. So among the 6 cases, only 1 case. That is this case over there. If I talk about this question, a prime number is what I am interested in. So what are the prime numbers over here? Is 1 a prime number? This is the first question which comes to my mind. I hope you have the answer for it. I hope you have the clarity that the prime numbers are the one which have only 2 factors. 1 is not having two factors, it's having only one factor. It's not a prime number. It's neither prime, it's not composite. I hope you have learned my first revision session related to real number. If you haven't done, now also you have the chance. You can go forward over there and get to know. 1 is eliminated. What about 2? Yes, 2 is favorable. Only 2 and 1 is a factor. 3 is favorable. 4? No, sir. 1 is a factor, 2 is a factor, 4 itself is a factor. 3 factor, it's not a prime number. 5, yes sir, again 6 not. So the probability of this event will be what? In total, 6 cases were there, and I am interested in 1, 2, 3. These are the 3 outcomes which are in my favor, or this is the event which I am interested in. So 3 by 6, the answer is simply 1 by 2. Clear cut answer. Simple thing, simple way forward. We also move forward to the next problem. This time they're asking, dice is thrown, find the probability of getting a prime number. A repetitive question. Why to go again? I don't know why it is at the first place. Let's remove it. Going forward, we are having a number lying between 2 and 6. Lying between 2 and 6. So I hope you have the count. Very simple. You have the count. Very simple. First is 1, 2, 3, 4, 5, 6. What I want between 2 and 6. I haven't told that 2 and 6 are included. If 2 and 6 are not included, so between 2 and 6, I can see numbers 3, 4, 5. In total, how many? 1 case, second case, third case. Total 6, the possible outcome. I want these 3 cases. So 3 by 6, again 1 by 2. And please don't write 1 by 2 as a common answer that every time 1 by 2 will be the answer. No. It might differ each and every time. You have to go by the formula and then understand which will be the case. We go forward to the next problem. Probability of getting an odd number when the dice is thrown. So this is again very simple. 1, 2, 3, 4, 5, 6. What are the odd numbers? Odd numbers definition should be clear. Mathematics is a holistic thing. It's a real life thing which you are dealing with. 1 is an odd number, 3 is an odd number, 5 is an odd number. Any number which is not divisible by 2 is an odd number. In total, among 6, 3 are even, 3 are odd. So probability are equally distributed over there. So out of the total 6, 3 cases, again 1 by 2. So enough of 1 by 2. We'll like to break this chain of 1 by 2 going forward. But right now 1 by 2 for the probability of odd number. And for the case of even number also, the probability will be 1 by 2. Is this an elementary event? No sir, this is not an elementary event. This is not an elementary event at the moment. Why? Because in this event we are having 3 outcomes possible. But in this case, sir, 1 by 2 plus 1 by 2, we are getting 1. Why is that? Because the 2 events over here, probability of odd and probability of even, are complementary. So even number, so odd will not be there. If odd is there, even will not be there. Interesting thing, right? Chalo, going forward. Next one. Even number already done. Ignore the problem, go forward. A number greater than 4. 4 is not included. So what we want? We want 5 and 6, only 2 cases. 5 and 6 are the 2 cases we are interested in among the total 6. So total 6, we want 2. So 2 by 6. Over here, finally, we have broken the chain of 1 by 2 as the answer. So this time we are having the answer which is not 1 by 2. It is 1 by 3. I hope you would be happy after seeing this part. Otherwise, you would have mugged up why to do the question in the first place if every time 1 by 2 would be the answer. No, that will not be the case. I hope you have the clarity. 1 by 3 is the answer over here. Going forward and coming to the final thing which deals with cards. This is an educational video. I am giving the disclaimer over here. Don't use it otherwise. So in case you don't know how to play with cards or what type of card do we have, we are not going to talk about how to play with cards. We are only going to talk about understanding what cards we have. In a deck of card, total 52 cards are there. Total 52 cards. All right, 52 cards. In the case of 52 cards, we have 4 suits. What are suits? These are the suits. Suits is basically a type. So this is one type, this is another type, this is another type, this is another type. Spade, club, heart, diamond. Names are different and are important. Spade, club, heart, diamond. Heart and diamond. Diamond looks like a diamond. Heart going by the normal terminology, basically these days people do make heart like this, but if you have learned biology, the heart is not of this shape. But yeah, heart and diamond somewhat related, The image is perfect. Club and spade. Be careful, people do get confused in this one. Club and spade. Club is this tree kind of a thing and spade is this leaf kind of a thing. So, tree and the leaf. Club and the spade. 4 suits. So, each suit, how many cards are there? Each suits in total 13 cards. This is basically the first one is what? The first one is a tree, which is club. So, total 13 for this one. Total 13 for the spade. Total 13 for heart and total 13 for diamond. In total what? 13 plus 13 plus 13 plus 13, or you can say in simpler terms 13 into 4, which is 52. Total 52. One more thing. 4 suits are there. 2 colors are there. You can observe heart and diamond. Heart and diamond. If diamond would be there, hearts would be there, right? So basically if money is there, everything is happy. If money is not there, things will be very difficult. So yeah, diamond and heart are related. Alright. So in this case, both are of red color. Heart and diamond. So we are left with spade and club and both will be of black color. So in total, 2 colors are there. Alright. And don't judge my spelling over here. I don't know which English we are following at the moment, American or English. So ignore that part. Over here, 2 colors, black and red. In the case of black, we are having 2 suits, spade and club. So in total, black color, how many? Black color, if I talk about, 26. If I talk about red color, 26. Again, the same total, 52. What differentiation we are having? We are having a differentiation of suits. We are having a differentiation of color. And let me introduce you to the third differentiation, which is based on the card itself. We are having numbers like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, we are having jack. This is a jack, which is represented by J. We are having a queen. We are having a king. J, Q, K. These 3, J, Q, K, are what? They are face card. On it, the photo is printed. Not exactly of which king, queen or jack. A representation of a king, a representation of a queen and a representation of a jack. So jack of all, king of none. So over here, king is there, king is greater than jack. In between, we are having a queen. In total, how many face card? We call all them as face card. In total, we are having how many? 3, 3, 3, 3. 3 into 4, total 12 face card. In one suit, 3 face card. In black color, 6 face card. In red color, 6 face card. Total 12 face card. Rest of them are number cards. This was the basic theory of playing cards. With this, you can understand any game. With this, you can solve most of the problems related to the cards. And most, I mean almost everything, right? So again, reiterating the differentiation among the cards, total 52. Based on the suit, 4 suits. Based on the color, 2 colors. And face card, number card. These were the distinction, or I must say the classification of cards we can do. So now is the time we apply this knowledge, what we have learned now. So here we have the first question asking us about a deck of cards. So every time they mention a deck of 52 cards. Total 52 cards are there. So probability of getting a king of red color. In total, 4 kings would be there. 4 kings would be there. If you remember, 4 suit, so 4 kings. We want red color. So red color. We are interested in what? Hearts king and diamond. Because these 2 are red in color. The rest of the 2 will be black. Club and spade. I am not interested in both of them. So out of the total 52, people do get confused. Sir, out of the total 4, we are having 2. 1 by 2 is the probability. No. Out of the total 52, probability of this case will be what? Out of the total 52, we are talking about how much? We are talking about a red color king. So total 2, not 4. So 2 by 52, which is 1 by 26. Answer. Very simple. This is about your understanding how many kings would be there and how many kings of red color. This is how this needs to be answered. Going forward, find the probability of getting a face card. We already talked about total cards we have is 52 and face card. Total we have J, K and J, Q and K. Let's follow the order, otherwise the king will get angry. So J, Q and K, and 3 in each suit. In total 4 suits. So in total 12 cards. 12 by 52. I hope we can do the simplifying over here and get the common answer. Right? So this is how we need to answer. You just need to understand the count correctly. Next one. Find the probability of getting a black face card. Black face card. Alright. Black face card. 3 cards, 3 face card in each suit. 2 suits are there. 2 suits are there. So in total 3 into 2, 6 face cards would be there. Out of how many? 6 out of total 52. 6 out of total 52. Understanding this calculation is important because over here the simple formula is again and again and again being used. So 3 into 2, that is 6. That is how the question needs to be done. Alright. So 6 by 52, black face card. Which black? We are talking about over here, which 2 suits? Club and spade. Club and spade. The tree and its leaf. The tree and its leaf. Going further, getting an ace. So I haven't talked much about ace. In total 4 aces also are there, right? In total 4 aces are also there. So total 4 aces out of how much? Out of, as usual, a pack of 52 cards. So out of 52, 4 cards. That's it. That means 1 by 13 over here. That will be our answer. Among each one suit, we'll be having 1 ace, and that is also how you can visualize the problem. So these are the basic problems related to the cards. Let's take one more. Getting a black card. In total 52, we are having 2 suits. 2 suits of black color. So 2 suits. So basically how many in one suit? 13. Total 26 of one color, and we are talking about black. So we are talking about what? We are talking about club and spade. 26 out of 52. That means 1 by 2 is what we are talking about. That is how things needs to be understood. Alright, 1 by 2 is our final answer. Let's change few problems. Sometimes we are talking about probability, so not limited to 3 cases. Let's take another case. This time we are talking about a piggy bank. A bank, certain students do have their piggy bank. Basically, they have saved lot of their pocket money. So, piggy bank contains 150 paisa coin. 150 paisa coin. Alright, note down each and every information. 50 1 rupee coin. 50 1 rupee coin. Alright, 1 rupee coin. Then they have 50 1 rupee coin, 20 2 rupee coin. How many? 20 2 rupee coin. And finally 10 5 rupee coin. 10 5 rupee coin. So now how many rupee does he or she has? I am not going to calculate this, you can calculate on your own. But I will do the calculation for in total how many coins he or she has. So he or she is having how many? 20 plus 50, 20 plus 10 is 30, 30 plus 50 is 80. So in total 180. 180 total coins. Total coins. And what they are asking us? They are asking us the probability when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin? If a coin comes out of the piggy banks, it might be possible that you have broken it, one coin somehow get out of the space provided to you. So probability of getting a 50 paisa coin will be what? Total number of coins 180. So possible outcome among all the cases, anyone can come out. But understand one thing. Now, you might say, sir, the probability of 50 paisa, there are 4 cases, either this one, this one, this one, this one. So 1 out of 4. No, that's not how things work. That's not how things work. Total 180 cases were there. It can be among the 100 coins of 50 paisa. It can be among the 50 1 rupee coin. It can be among any of these two. Total 180 are there. We want 50 paisa. We want this case. Any of this case would happen. Any of this case would happen. That means any of the case where 100 rupee coin, not 100 rupee coin, there is no 100 rupee coin at the moment. Yeah, that is a different nature. But yeah, 50 paisa coin comes out, 100 possibilities are there. Why? Because 100 coins were there at the first place. So 100 cases would be there. 100 cases. So 100 by 180. 100 by 180, very simple. That will be the probability of the 50 paisa coin, 50 paisa coin. If I change the situation, 5 rupee coin will not be a 5 rupee coin. Interesting. The second question is will not be. People will misread the question. They'll say 5 rupee coin, immediately going for the number that 5 rupee coin are 10. So 10 by 180. No. Wait for it. Not be. So 10 are 5 rupee coin, not 5 rupee. 180 minus these 10. So how many we have? 170. So the probability of not 5. See, not 5. Not. This is not E. This is we don't want this even. So this will be what? 180 total. 170 is what we are interested in. 17 by 18 will be the answer. Very simple. This is how we need to proceed. Probability of getting a 2-digit number when we are having disk. So we are having like compact disk we were having. So multiple disks were there. Now is not the time because now we have huge memory in our mobile phone, huge memory in our laptops, huge memory in our computer system. But at some time we were using the compact disk CDs, and in the case of CDs we have plenty of them. We have given the number 1, 2, 3, and like the case of marble, we have given the number up till 90, from 1 to 90. So in that case, if I talk about a 2-digit number, now interesting thing is, when I ask this question with most of the students, they say 1 to 90. That means, so first we'll be having up till 10, we'll be having 1-digit number. Then after that, so in total, so 80 would be there. This is a simple understanding which you need to think about, that how many 1-digit numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Only up till 9. 10 is not a single digit number. It's a double digit number. So out of 90, how many single digit? Only 9. If I subtract 9, what I'll be getting? 81. So total 2-digit number. Total 2-digit number is 81. 81 cases would be there of 2-digit number. So probability of 2-digit number would be what? Out of the total 90 cases would be there, that will be taking out. So out of the total 90, 81 will be the case which will be 2-digit number. So ultimately you can do the division and write down over here simply 9 by 10. 9 by 10. This is of 2-digit number, and that is how the questions of probability will be. So the next question is asking about a perfect square number, perfect square. So few students would be there, they'll be searching from 1 to 10, they'll be, okay, 3 square is there, then any other, no, I'm not able to. This is not the right method. Save your time, save your time. The numbers start from 1. I know 1 square is 1. Alright. Going forward, the last number we have is 90. Okay. So close to 90, which square can you remember? Close to 90, I am able to easily recollect 81. 81. What is 81, sir? 81 is 9 square. Because after 9 square, if I go 10 square is 100. The numbers are up till 90. So how many numbers square? 1, 2, 3, 4, 5, 6, 8, 9. In total 9 numbers are there whose perfect square will lie between up till 90. So the probability for perfect square is very simple. It will be equal to what? In the denominator, how much? In the denominator, as usual, 90. And how many we want? 9. 9 by 90. 1 by 10. Very simple. As easily done. One final problem in this particular case, we are having that number divisible by 5. This is also one of the case. They ask about the prime number, they ask about even number, they ask greater, lesser, greater, equal to, or divisibility, all these cases. Divisible by 5. There are multiple ways to think about it. The easiest way to think about it, see, if I ask you up till 10, how many numbers are there which are divisible by 2? So 5 is there, 10 is there, 2, right? From 20 to 30, how much will be there? Or 11 to 20, how many numbers divisible by 5 will be there? 15, 20, 2. So up till 1 to 10, 2. 20 to 30 will be 2. 11 to 20, 2. So up till we are having these 9 cases. 9 cases. In one case, 2. So total how many? 2 in one case, in total 9 case, 18. In total 18 cases would be there, numbers which are divisible by 5. Or easy way of thinking it, 90 divided by 5, 18. Total 18 numbers are there which are divisible. Or Also, you need one more method. Think about it is a AP. And AP, you are having the value of A, you are having a value of D. What do you want? You want the value of N. And the last number, AN, is also provided. I hope you have done the revision for AP. If you have done, this method is also fine. But choose a method which is easily understood and you can easily calculate. So going further over here, in total how many numbers? 18. Out of total what? Divisible by 5. Total 90 numbers. How many numbers are divisible? 18. 18 by 90. You can do the calculation over here and you will get the clarity over here. You will get the clarity over here. So these were the range of problems which can come. These were the range of problems which can come up. And I have given you a single formula that will work for all of them. Other than that, anything? If you are an exceptional student, if you want to think ahead of all of other people, then you can think of cases like what? You can think of cases like, till now I talked about tossing a single coin. Tossing a single coin. So there might be a possibility that two coins tossed simultaneously. This is one of the experiment. Two coins tossed simultaneously. Think about it. Think about the sample spaces which will be coming up. So what are the possible outcome? In that case, we'll be having different case, like head would be there, head tail would be there, tail head would be there, tail would be there. What is this? What is all this? This is nothing new. Basically, we are talking about over here. On one coin we are having head, on one coin we are having head. Both the coins are having head, both the coins are having tail. One case head will be there on first one, the second one tail will be there. And these two are different. Don't mix them saying that okay, so HT and TH are the same thing, right? No, they are not the same thing. Why they are not the same thing? Because this is head on the first coin, tail on the second coin. Tail on the first coin, head on the second coin. So yeah, they are different cases. In total, 4 possible outcomes. There is an easy way also. Let me give you a glimpse ahead. Let me give you a glimpse ahead. So if 3 coins would have tossed simultaneously, how would have calculated? Again, you can always spread out the sample spaces. But directly if someone asks how many total possible outcome would be there. See, tossing a coin, a single coin, 2 possible outcome, right? 2 possible outcome. So simultaneously how many coins you are basically being tossed. So that value, if you say that is n, so this will give you the possible outcome. Two coins were tossed simultaneously, n value is 2. So 2 square is 4 possible outcome. 3 coins being tossed simultaneously, 2 raised to the power 3, that means 8. 8 will be the total possible outcome. Another case you can think of, in that this was the case of head and tail. If 2 dices are rolled simultaneously, in this case what is going to happen? In this case also, when a dice is being rolled, how many possible outcomes are there? Single dice is being rolled, so total 6. So total 6. And this time simultaneously how many? Simultaneously 2. So 6 raised to power 2. Total 36 possible outcome. And what 36 you can think of? 1, 1, 1, 2, 1, 3, 1, 4, 1, 6, like this. And like this finally we'll be having 6, 1, 6, 2, 6, 3 and so on. Up till 6, 6. Total 36 will be the possible outcomes. If someone told you that 3 dices were rolled simultaneously, the formula will work as usual, which we have learned about, 6 raised to the power n. That means n value will be 3 this time. Why I am telling you these cases? These are advanced cases. There is a high possibility, or I would say high probability, that this will not come in your examination. But giving you a glimpse how far you can go forward. And in these cases, you can be asked for a question which is asking for, let's say, among these, getting 2 heads at the same time, getting 2 tails at the same time. At least 1 head should be there. These are the possible cases, possible scenario of the question which can be made. So my part was to just give you a hint that what are the possibility of the question, what are the range of questions possible. This is a very fascinating chapter. I told you the 2 reasons behind it, no formulas involved, no calculation involved. It's all about the visualization, imagination of a person, and highly realistic. We are contemplating the chances of multiple events at the same time in our favor. What will happen tomorrow? Will I be able to pass with good marks? Will I have a good career? Will I have a good life? You can think about it. That's all we have in the case of probability. Had a great time. Enjoy yourself. Take care. Bye everyone.